Go ahead and give this a try. We need the value of the f of negative half for the function f of x equals 8 plus 3. Who's got it? Brian? Negative what? Negative 1 is correct. All right, so if you remember, when it's in the parentheses like this, when you have a number inside the parentheses, what that is doing is that is substituting for the x. So we need to do the same thing in the actual function. The x is coming out, the negative 1/2 is going in. So we got 8 times negative 1/2 plus 3. Half of 8 is 4. Positive times negative makes that negative 4. When the signs are different, you subtract and use the sign of the bigger number. So that's how we get the negative 1. Any questions on that? All right, give that one a try then. All right, who thinks they've got it? Shane? Negative 18 is correct. All right, so same idea with function notation, just slightly different. This time it's saying f of x equals 7. So instead of the 7 replacing the x, the 7 is going to replace the whole f of x. And then we just have an equation we got to solve. So we got 7 equals 2/3 x plus 19. Subtract 19 from each side, cancels there. Try it again, cancels there. Left side, signs are different, so we subtract, use the sign of the bigger number. Equals 2/3 times x. So we're going to divide by 2/3. I got negative 12 divided by 2/3. We do keep, change, flip. So you got negative 36 over 2, which, like he said, is negative 18. Okay? Any questions on that one? There's kind of two different ways of doing those or looking at those. So let's get some trickier stuff then. Same idea, just a little bit trickier functions. This function here, 2x squared minus 4x plus 9, that is a quadratic function. We will be doing things with quadratic functions later in the year. One of our whole units will be quadratic functions, but we do have to work with them for the function notation as well. All right, who thinks I got this one? 25's correct. All right, so just like with the other ones, it's in the parentheses. That means we're substituting for x. We do have two places where we have to do that in this case. So if I write this out, I got 2 times 4 squared minus 4 times 4 plus 9. That's substitution right there. Everybody good with that part? Yeah? All right, so then we got to follow our order of operations. What comes first? Exponents or multiplication? Exponents. So we got to do that 4 to the second power, the 4 squared, before we do 2 times 4. That's been a problem other years that I've noticed. Sometimes they try to multiply first. But so we'd have 2 times 16 minus 4 times 4 plus 9. 2 times 16 is 32. 4 times 4 is 16. And we got plus 9. Just do our math going from left to right. 32 minus 16 is 16. 16 plus 9 is 25. You gotta remember also with your order of operations, even though you think of it as PEMDAS, or please excuse my dear Aunt Sally, addition and subtraction are done at the same time going from left to right. So you don't add first and then subtract, okay? Did any of y'all have 7 as your answer? No? So that's good at least. All right, so let's try another kind of tricky one. This time, the x is the exponent. That function is an exponential function. That also will be another unit that we do later this year. Riley, what you got? 96 is correct. All right, so the x is our exponent. Still has the 5 in parentheses. Still means we're doing that substitution. All right. So when I do that, I got 3 times 2, because next to the parentheses like that, that's multiplication. And it's 2 to the 5th power now. All right, 2 to the 5th power, we got to remember that's not 2 times 5. That's 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 makes 32. So we got 3 times 32. 3 times 32 then is 96. Okay? With exponents or the quadratic functions, those are really about as tricky as some of these get. Sometimes we got to do some math with them though, or we got to make some comparisons. All right, so this one is asking for the lowest positive integer value of x where g of x is greater than f of x. All right, so there is no real shortcut to doing something like this, okay? If we were using the calculators, you could graph them and find where they intersect, and then it'll be the next x value. This type of question or this type of problem is typically on the calculator inactive though. So showing you how to do it on the calculator, not super helpful for that. So what we would want to do is we're going to take some x values and we're just going to plug them in and compare. So if I make these comparisons, I'll have my f of x and my g of x, okay? And I'm just going to make a little table. All right, so we'll start with x equaling 1, then we'll do 2, 3, 4, 5, and we'll just keep going until we find an answer, okay? So when I start with 1, what I'm doing is I'm putting 1 into each equation. So I'd have 3 times 1 plus 19. 3 times 1 is 3 plus 19 makes 22. For g of x, I'd have 3 to the first power. Well, 3 to the first power is just 3. If I do 2, same idea, I'm just switching 2 in for the x's. So 3 times 2 is 6. 6 plus 19 makes 25. For g of x, what's 3 to the second power? 9. Generally, they follow a pattern, so that can sometimes be helpful once you figure out the pattern. For f of x, it's going up by 3 each time. All right, so you might have needed to do one more to see that. If we did one more, 3 times 3 is 9, plus 19 makes 28. 3 to the third power is 27. So what's happening is this is going up by 3 each time. So the next one would be 31, then we'd have 34, right? See what I'm saying? And the g of x is multiplying by 3 each time. So next would be 81, and I don't have to go any higher. That would be my answer. Okay? I've seen these phrased this way where it's like the first value that g of x is higher. And I've also seen it kind of phrased as like the last value where f of x is still lower, in which case the answer would be 3. Or f of x is still higher, I mean, sorry. Okay? Any questions on that? Really, like stuff like that's about as complicated as these problems get.